This video is on IP addresses. Let's take a look at IP version 4, which is the more popular IP addressing scheme used on the internet these days. So IP version 4 was developed in the early 80s. An IP address that is based on IP version 4 has 32 bits. So with 32 bits, it is possible to have 2 raised to power 32, which is approximately equal to 4 billion unique IP addresses. So when the internet first got developed, it was thought that internet is only going to be used by universities or big government agencies or large business organizations. So they thought, we could just provide internet to these kind of agencies, like the government agency or the business organization or universities. What was not thought at that time was that an ordinary end user who sits at home would want to connect to the internet, right? So that was not the idea then. So at that point in time, when they thought that there are 4 billion IP addresses possible, they thought this was going to be a huge number, because they thought it would never come to a stage where we are going to need 4 billion IP addresses. So they thought this was a huge number, so they settled with 32 bits in the IP address. At that time, they broke an IP address logically into 2 parts. They said an IP address will have 2 parts. One would be the network ID and the other part would be the host ID. So a whole network like this LAN here, like this LAN, this local area network, would have the same network ID, would have the same network ID. So this network would be identified, by this network ID, right? And the computers within, like this computer A, B, C, D, will have their host IDs, So for example, IP address of this computer A would be equal to network ID plus host ID of computer A. So this collectively would form the IP address of computer A. What should be noted is, because A, B, C and D, all of these computers are on the same network, their network ID is going to be the same. However, the host ID is going to be different. So when you combine network ID and host ID together, then collectively the IP address of A is going to be different from the IP address of B, which is going to be different from the IP address of C, which is going to be different from the IP address of D. However, the network ID part of the IP address for A, for B, for C and for D is going to be the same, because they all are residing, or they are all part of the same network. So whatever network ID this net has, right, that network ID is going to be present in the IP address of C. That network ID is also going to be a part of the IP address of D and B and A. Okay, so let's assume that the network ID of this local area network is 200.39.87.0. So what can be a possible IP address of computer A? Well, the network ID is going to be the same, so this part is going to stay the same. So it's going to have 200.39.87, and this can have .1, right? So this would be the host ID, this would be the host ID, and this part here is going to be the network ID. Okay, how about this computer? This can have an IP address of 200.39.87.2. so this would be the network ID, and this is the host ID. And this would be the network ID. And this computer D can have an IP address 200.39.87.3. This here can have an IP address of 200.39.87.4. so you see, all of these computers have the same network ID, only the host ID part is different. So in the early days, in this IP addressing scheme, basically there could only be 3 different types of networks. We could have class A networks, class B networks, or class C networks. So out of the 32 bits, right, we would separate bits for the network part and the host part. For example, in a class A network, we had 8 bits reserved for the network, and the remaining 24 bits were going to be used for hosts. So these 24 bits could be used to give host addresses, and the first 8 bits were going to be used to give network addresses. And even in the first 8 bits that we had, this first bit was reserved, or it was fixed to 0. So this was always going to have a value of 0. So this bit was always going to be 0. So this had a fixed value, which basically meant that out of the 8 bits, if this first bit was always going to have a value of 0, we technically were left with 7 bits. We were left with 7 network bits, because the first bit had a fixed value of 0. And in class B network, the first 2 bits were fixed. And they were going to have a fixed value of 10. So in fact, out of the 16 bits that were reserved for networks, since these 2 bits are fixed, we only had 14 network bits available, right? Because the first 2 bits were fixed. And in case of a class C network, the first 3 bits were fixed. 1, 1, 0. So this was a fixed value for the first 3 bits. And because of that, now effectively, instead of 24 network bits, we had 21 network bits available. So we had 21 network bits available to assign a network, some address, some combination of these 21 network bits to represent one network. Okay, so these bits that were fixed, these 2 bits, this 1 bit here and this 1 bit here, these are called the prefix. So why did we have a prefix in these IP addresses? What was the point of having these prefixes in the IP addresses? See, when a router receives a packet that is, let's say, coming from this side, that packet has some, part of that packet are IP addresses. So when a router receives an IP address like this, for example, these 32 bits, right? If the router receives a packet with this IP address, right? This is an IP address, remember? This is an IP address in binary form. So this is how the router is going to receive this IP address. Now the router can quickly take a look at the prefix and determine whether this is a class A IP address or a class B IP address or a class C IP address. Looking at this prefix, because it's starting with 0, the router knows that this is a class A IP address. This is a class A IP address. Looking at this prefix, the router would know that this is a class B IP address, and looking at this prefix, the router would know that this is a class C IP address. So these prefixes could not get mixed up. So as soon as the router received an IP address, it would instantly take a look at the prefix to determine whether this is a class A address or a class B address or a class C address. Okay, so why was it important for the router to determine whether this was a class A address or a class B address or a class C address? Well, doing this, taking a look at the prefix, the router would know how many bits are reserved for the network. So the router would know how many bits are reserved for the network. Because it's starting with 0, that means this is a class A address, and the router would instantly know that the first 8 bits have been reserved for the network in this case. Looking at this IP address, the router will see that this is the prefix is 10, so the router would know that the first 16 bits are being used for the network address. So this part is going to be what? This part is going to be the host address, and this part here is going to be the network address. In this case, this part here is going to be the host address. And now we have 110. So this means that the first 24 bits are going to be the network address, and the last 8 bits are going to be the host address. So the router would take a look at the prefix and determine whether this is a class A address or a class B address or a class C address. Okay, this is the form in which the router sees IP addresses, but we humans do not like to view IP addresses in this form. We would rather want to see these IP addresses in decimal notation. And to do that, we separate these 32 bits into groups of 8 bits, right? So the first 8 bits, then the next 8 bits, then the next 8 bits, and then the next 8 bits, right? We're going to separate them into 8 bits each, and then we're going to convert them into a denary number, and we can do that by applying weights 1, 2, 4, 8, 16, 32, 64, 1 to 8, right? 1, 2, 4, 8, 16, 32, 64, 1 to 8. So after applying weights, we convert these 8 bits into a denary number. So what the end result is that we get this IP address, 86.219.36.170. Now we know that this is a class A address, so this is going to be what? This is going to be the network address part. The first 8 bits are going to be the network address part. So the network address in this case, the network address is going to be 86.0.0.0. What I've done is I've set all the host bits to 0 just to indicate that this is the network address, right? And the host address from this IP address, from this whole IP address, right, the host part is going to be what? I'm just going to set the network address part to 0, and the remaining is going to be what? The remaining is going to be the host address part. So